All right, welcome to chapter 4, where we are collecting data. Today we are looking at section 4.1, sampling and surveys. So for learning targets today, you should be able to identify the population and sample of a statistical study. You should be able to identify voluntary response sampling and convenience sampling, and explain how these sampling methods can lead to bias. Describe how to select a simple random sample with technology or a table of random digits. Describe how to select a sample using stratified random sampling and cluster sampling, distinguish between the two, and give an advantage of each. And then explain how undercoverage, non-response, question wording, and other aspects of a sample survey can lead to bias. So first things first, population census and samples. The population in a statistical study is the entire group of individuals we want information about. So think about like how the US every so often, I can't remember how often now, they do a census out there where they try and collect data on everybody in the population of America. Things from how many people live in a household to race and ethnicity backgrounds to income, a way just to collect data, and they use that information for the government, but also just it's public information, so then people can use it for their own studies also. So it's beneficial for a lot of people. Now, the one thing to keep in mind is that the census isn't actually a true census in America. It would be nearly impossible to survey every single individual in America. There's just too many of them. And so they do a very good job of it, but it's not a perfect census. A perfect census collects data on every single person in the population. Um, a sample, on the other hand, is a subset of individuals in the population from which we actually collect data. So we'll give a lot of examples. An easy example to think about is like if we were talking about did kids prefer the open campus lunch at school? If we surveyed every individual student at Naperville North, that would be a census because we're talking about the students at Naperville North liking the open campus. And then a sample would potentially be using our first period or second period stats class. And then using that data to talk about everybody else. So that's the difference between census and a sample. Here's a nice little visual. Population is a full group. A sample is a subset or a portion of that group. We take the sample, collect data from them, and then we use that data to make an inference about the population. So since it is unrealistic and unlikely and nearly impossible to collect data on every single person, or do a census, we take a sample, and hopefully our sample is a good enough representation of everybody that we can generalize it or make inferences using that data for the whole group. So we often draw conclusions about a whole population on the basis of a sample. Choosing a sample from a large varied population is not that easy though. A sample survey is a study that collects data from a sample that is chosen to represent a specific population. So when you're planning to do a sample survey, you want to decide what population we want to describe what we want to measure, and describe how to choose a sample from that population. And we'll see a bunch of different ways to choose a sample and which one is more beneficial for which. There's a couple, well, the biggest or the easiest bad way to sample is what's called a convenience sample, and it's choosing individuals from the population who are easy to reach. So, for example, the sample I described earlier about surveying students at Naperville North, if I just surveyed my first and second period, very easy to sample. However, it is very bad because it's just a convenience, and it often produces unrepresentative data. So what do you think that would be? Well, in stats, there's basically only juniors and seniors. So maybe they really like off-campus lunch because they have cars and are able to go and drive. But maybe the freshmen and sophomores who just get stuck at school and don't really utilize it, they feel indifferent or they don't really like it because they're spiteful of all the upperclassmen getting to leave. So that our convenience sample could have potential negative consequences because we overestimate how much people like the data, how much people overlike off-campus lunch, which would skew the data. So the design of a statistical study shows bias if it is very likely to over or underestimate the value you want to know. So the example I gave, it probably overestimated it because we have a lot of juniors and seniors in our class. And like another caution, bias is not just bad luck in one sample. It is the use of the sampling that causes that bias, or the method in which we did potentially causes that bias. So, like I said, convenient sampling will almost always result in bias, but so will some others. So, the other main one is voluntary response bias, or voluntary response sampling, which allows people to choose to be in a sample by responding to a general invitation. So, this is very common with like calling in to give your examples or your opinions. So, think about like both internet polls, along with call and text and write-in polls, rely on voluntary response sampling. This is a little if you think back to like American Idol, those people who would call in to vote for their favorite person, that's whatever that percentage is that that person won, that's not the true percentage of the whole population, right? It's just the people who are willing to pick up the phone and call and to put in their opinion. Now, the reason why these are usually very biased is that the people who are willing to make the call, go out of their way to call, do an internet poll, whatever the case is, they're usually very passionate either direction. So either the person who loves that singer so much they're going to go and call 10 times just so that they get 10 votes for them. Or maybe it's the opposite. Maybe the Naperville, the town of Naperville, is trying to collect data to see if they should put a new curfew out for high school students. And maybe there's some older people out there who want to put in that curfew really bad, so they are going to call multiple times because they're very passionate about this and they want this curfew because they think it's beneficial. So they're going to overly call and kind of skew the data in that sense. So those are two bad ways to sample: convenience sampling and voluntary response sampling. Now we're going to talk about some good ways to sample. The first one is simple random sample. And I want you to when we get to this definition, I'll kind of highlight it. But a sample chosen by chance rules out both favoritism of the sampler and self-selection by response. So if you actually do get a good random sample, it eliminates those people who, there might still be some people in your sample that are very passionate. However, it's not just relying on those people who are super passionate. And it also rules out some of the other potential problems of the convenience sampling just because you have a random and hopefully a more accurate representation of the whole population. So random sampling involves using a chance process to determine which member of a population are included in the sample. A simple random sample of size n is chosen in such a way that every group of n individuals in the population has an equal chance of being selected as a sample. And I want you to make sure you write that down because it's very common that they ask some type of question like this on the AP test, trying to get you to remember the definition of a simple random sample. We abbreviate simple random sample with an as SRS, and a lot of people will just call it an SRS, and it means that every group of individuals has an equal chance of being selected in the sample. Right? So thinking about our sampling first and second period stats class, obviously that's not a simple random sample because there's a lot of people in the school that don't even have a chance of being sampled. There's only 60 kids who have a chance out of the over 2,000. So that's why that's not a simple random sample. Simple random sample gives size n, or every size n group has an equal chance of being selected. All right. There's a couple ways to create an SRS, and this is also very common. They'll ask you to describe a process or how you would go about doing an SRS. They won't always make you do one, but they will often ask you to describe how you would go about making one. So first, you're going to label each individual in the population a distinct numerical label from 1 to whatever, where n is the number of individuals in the population. Then you're going to randomize. You're going to use a random number generator to obtain n different integers from n to however big your sample size is. And then you'll choose the individuals that correspond to the randomly selected integers. All right. So that's if you're using a random number generator. The second one is using a table of random digits. We'll show an example of this in class also for you. But first, you're again going to label, give each member of the population a distinct numerical label with the same number of digits. This is the one thing that's important. Up here doesn't matter how long the digits are because your random number generator is just pulling integers. But you want to make sure they're all the same number digits. So if you're going to use all 2-digit numbers, the first individual is really 0, 1. The second individual is 0, 2, and so forth. So that when you get to 32, right, they're a 2-digit number as well. So you're going to look for all those 2-digit numbers. If you are sampling, let's say 200 people, and now you get into 3 digits, that first person in your list is really 0, 0, 1. The next person is 0, 0, 2, and so forth. If you just said, hey, they're 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then go from there, well, what's the difference between getting a 1 and getting a 10? So they have to be the same length. That's their identifying markers. So you'll label them all, then you'll randomize. You'll read consecutive groups of digits of the appropriate length from left to right across a line in Table D. Ignore any group of digits that wasn't used as a label. So if we were sampling 1 to 50 and you get the number 62, 73, 81, you just skip those over until you get your next group. And also that duplicates the label already in the sample. You're not going to sample the same person twice. So if it ever duplicates, you just skip that as well. And then you stop when you've reached the number of people you want. And then you select those who you the individuals that correspond to the randomly selected individuals.
Looking for feedback?
Sorry about that. So here is an example of how to do an SRS with a Table D. So you have 28 individuals, 28 hotels, and you want to do an SRS of 4. So 28, they're all 2-digit numbers. So we have 0, 1, 0, 2, 0, 3, so forth, 0, 9, 10, and then so forth from there. Here is our list of SRSs, our list of random digits from Table D. We're going to start from left to right, and we're going to look, since our samples or our numbers are 2 digits, we are going to look for 2-digit numbers. So we're not looking at 6, we're looking at 69. 69 is not in our sample, so we skip 69. 05 is in our sample, so we're going to use 05. Then we get 16, hey, that is in our sample. 48 is not in our sample, but 17 is. 87 is not, and then 17 is. Oh, but sorry, I jumped again. Let me go back. So 17 is in our sample. However, we already sampled 17, so we're not going to sample that one. 40 is too big. 95 is too big. 17 pops up again, but we've already sampled it. Don't sample there. 84 is too big. 53 is too big. 40 is too big. 64 is too big. 89 is too big. 87 is too big. And then we get to 20, which is in our sample. So we're going to survey number 20. All right, so we skip over those repeats. And when you're describing your relationship and describing the process of doing this, you also have to explicitly say, I will skip over any repeated numbers so that the grader knows what you're going to do during repeats. All right. So the four hotels that we will survey are Beach Castle, Radisson, Ramadan, and Sea Club. Now that was just an SRS. There's multiple other ways to do it. One of the most common alternatives to a simple random sample is called stratified random sampling. And there's one main benefit here that we want you to understand. So stratified random sampling are built by these strata. Strata are groups of individuals in a population who share characteristics thought to be associated with the variable being measured in a study. So, for example, going back to that lunch, the off-campus lunch at school, we might use strata as the different classes: freshmen, sophomores, juniors, and seniors. Each one of those strata, there might be some other information between there, depending if it's a freshman or sophomore, junior, or senior being sampled. So those strata are people who are in a shared characteristic, that characteristic being the year in school they are. And then we'll use those stratas to do our simple stratified random sampling, which selects a sample by choosing an SRS from each stratum and combine the SRSs into an overall sample. So we break them up into the 4 classes, and then we're going to take, let's say, 100 people SRS from each sample, from each strata. So 100 freshmen, 100 sophomores, 100 juniors, 100 seniors. And we would sample those hundreds. And we would use one of those previous SRS methods in order to obtain those individual 100 samples. Stratified random sampling works best when the individuals within each stratum are similar, or if they're in homogeneous groups with respect to being measured, and being there are large differences between the strata. So like I said, you can make a pretty good case that a freshman might answer differently than a senior to the open campus lunch. So it'd be a good idea to kind of separate them and survey them each individually and then put their data together. When we can choose strata that have similar responses within strata, but different responses between strata, stratified random sampling gives more precise estimates than a simple random sample of the same size. Again, you might get more information knowing how the freshmen, the sophomores, juniors, and seniors each individually respond, and then collectively as a whole. Another type of sampling is called cluster sampling. So where stratified sampling, you are sampling based on a homogeneous group, those groups having some characteristic that puts them together. Cluster sampling is kind of the opposite. You're going to put people in clusters based on where they are, and the individuals are hopefully like they're close in proximity, but also they kind of have something in common. So a cluster is a group of individuals in the population that are located near each other. Cluster sampling selects a sample by randomly choosing clusters and then including each member of the selected cluster in the sample. So the big difference here is that in stratified sampling, you break them up by strata and then you take an SRS of each stratum. So not everyone in the strata gets selected. Only 100 freshmen, 100 sophomores, 100 juniors, and 100 seniors get selected. In cluster sampling, you put them in clusters, you randomly select the clusters, and then you sample everyone in them. So the part where it gets randomized is different. Stratum, you split them up into groups, and then you randomize within the groups. Clusters, you split them up into groups, and you randomly select the groups and survey everybody inside that cluster. So cluster sampling works best when the individuals in each cluster are heterogeneous or mirroring the population. So let's say that you surveyed let's see, maybe we were surveying the elective classes, right? We would expect each elective class to be similar. I mean, if we picked senior foods, those are going to be only seniors. But if you picked food 1 or 2 or ceramics or art or drawing, those would be pretty heterogeneous groups. You're going to get a wide variety of students in them. And then we'll put them all into their own cluster, and then maybe we randomly select the 3 clusters that we're going to sample, and we sample everybody in that cluster. And cluster sampling is often used for particular reasons like saving time and money. So if we're thinking about on a bigger scale, maybe so going back to that idea of Naperville's trying to sample if they should implement a early curfew for young people, then they might go ahead and break the city of Naperville into clusters. Let's say each block is their own cluster, and then they randomly select, let's say, 50 blocks, and then they go door to door and sample each individual on those blocks. We would expect each block to be relatively the same or a heterogeneous group there, and it'd be a lot easier to sample those 50 blocks than to randomly survey 100 or 200 houses scattered throughout Naperville. Because at least on those blocks, everybody is right next to each other, and you can survey the 20 houses on the block a lot quicker than if you had to drive from one house to 4 blocks away, survey that house, drive another couple blocks, survey that house, drive another couple blocks, survey that house. The clusters are all they're relatively close together, so it makes it easier. and saves money. Another way to choose a simple random sample is systematic random sampling. Systematic random sampling selects a sample from an ordered arrangement of the population by randomly selecting one of the first k individuals and choosing every k individual thereafter. Systematic random sampling is particularly useful in certain contexts, such as exit polling at a polling place on election day, because an unknown number of voters will come to the polling place that day. I think the easiest way for me to think about it is think about like the kids in the classroom. So we want to survey, let's say, 8 people in the classroom. I do a random number generator. The number is 4. So I'm going to randomly select every fourth person. So I start with one individual, and then I just count. I go up and down the rows, and I count 1, 2, 3, 4. I survey them. I skip them, survey the next person. Skip, survey the next person. Skip, survey the next person. Skip, survey the next person. And you keep doing that until you run out. And if you still until you hit how many people you want to sample, or if you hit the end, you just start over again and you skip over the person you've already sampled. So that would be systematic random sampling. Just be careful if there are any patterns in the way that the population is ordered that coincide with the pattern in the systematic sample. The sample may not be representative of the population. So if you, I'm trying to think about our example. Let's say we were doing the systematic random sampling at a school-wide assembly where all the grade levels are there, and let's say they're already split up by like freshmen, sophomore, junior, seniors, and you just start going, but you're only in the freshman class, and say you only sampled 100 people, you might hit only the first. You might only get through all the freshmen and some of the sophomores by the time you hit your 100 people you want to survey, and you never even count those juniors and seniors because they're on the other side of the gym. So you want to make sure that there isn't a reason that you might skip people, or that a pattern might emerge that skews the data also, or the potential sample there. So is that so? Those are all the different sampling methods. So bad sampling is convenient sampling and voluntary response bias or sampling. Good sampling is an SRS, stratified random sampling, clustered sampling, and systematic random sampling. Right. Next, we're going to talk about what can go wrong with sample surveys. So the use of bad sampling methods often leads to bias. Researchers can avoid these methods by using random sampling to choose their sample. So hopefully we get a good sample. If we have a bad sample, then it's hard to trust that the data that was collected can be used to talk about the whole population, because you could be excluding some groups, or it's just not an accurate representation of the population. So that's what could go wrong with the sampling process. But other problems conclude once you have, even if you have a good sample, you can still have other problems. All right, and that's where your sample surveys can be difficult that you want to avoid. So the first thing you want to avoid is undercoverage. This occurs when some members of a population are less likely to be chosen or cannot be chosen in the sample. So, for example, surveying just our stats class, like I said, that convenience sample, you're going to get undercoverage. There are no freshmen in my stats class. So no freshmen are going to be included whatsoever. So they are undercoverage. They have been excluded from the survey. So that's one thing you don't want to happen. The next is non-response bias. This happens after you've already conducted your sample. You've chosen the 100 people you're going to sample, and now you go and survey them, and now an individual doesn't want to be sampled, or they can't be contacted, or they refuse to participate. An example of this would be, let's going back to our cluster sampling about you're walking around this one neighborhood or this one block in Naperville, knock on the door, no one's there. That's non-response. Another one, you knock on the door, they say, no, I don't want to participate, non-response also. So non-response is when individuals who have been selected cannot or will not answer and be a part of your survey. And third is response bias. This occurs when there's a systematic pattern of inaccurate answers to a survey question. It's a very textbook definition. There's two major ways that response bias occurs. One is the wording of a question. Like we said, if you said like, if you're trying to see how people feel genuinely at Naperville North, and you said, how do you really feel when you walk in the doors at Naperville North versus how do you feel when you walk in the days of Naperville North? Putting that really in front of it might cause somebody to think about or feel differently. It might also, another option where wording of the question might be wrong, might be like, hey, write 2 things that make you happy on a piece of paper. And the next question is, so how do you feel today? Well, writing 2 things that make you happy might skew your data and make you feel just generally more happy because you're thinking about happy things when you then answer the next question. So wording of the question is one form of response bias. The other is the person giving the survey might influence your responses. The most obvious or the most easy way I remember this is, let's say the school's trying to figure out how many students, how many students do their homework every night. Well, if it's the dean coming around the school and pulling you out of class and saying, hey, did you do your homework tonight? The student's going to probably say yes because they don't want to get in trouble. Versus if it was just a random person saying, hey, did you do your homework tonight? They might be a little bit more honest with you and actually be truthful. So the person in your authority might skew the data. Another example might be like if the police are involved or asking any legal questions, might be it. Putting your name on a survey might also skew the data because you don't want to have your name associated with it, especially if you're giving positive or negative feedback. You might not want your name associated with that. So that could be a form of response bias as well. So there's a lot of things that fall into that response bias. It's just something that might skew the data or cause a pattern of inaccurate answers to come out. Precaution. Some students misuse the term voluntary response to explain why certain individuals don't respond in a sample survey. Their belief is that participants in the survey is optional or voluntary, so anyone can refuse to take part. What the students are describing is non-response. So if you've already been selected for the sample and choose not to respond, that's non-response. If you choose to respond into a survey, this is before any survey occurs, like you seek out the survey, that's voluntary response. So those are the difference. If you seek out being part of the survey, that's voluntary response. If you were selected for the survey and choose not to respond, that's non-response. All right. And that is it for this section. So you can see the learning targets here. You can pause if you want to see them. And that is it. Have a great rest of your day, everyone.